Probably we can start. Let me share my screen first. Okay. You see this page, right? Course website page. You see the screen or not? Yeah, thank you. All right. Okay. I hope you guys downloaded this Google Colab page. Is anyone having any problem loading this file? So the one thing you can do is that download this file and save it to your Google Drive and load it from there. So it will be there. And okay, first let's see what is the content for today's practical. It's this practical is about how to load the data sets using Keras or Pytorch. Okay, and look into the data set and check certain statistics and do some classification, which Yoni just spoke about using linear regression. We touch three data sets today. One is fashion MNest itself, and then we have CIFAR 10. And if you have any questions, please drop message in the chat, okay? So once you have this file, you can actually look into the content here. And few things I would like you to do is that go to edit and clear all the outputs, okay? Let's have a fresh start and execute this file with me, okay? And you can ask questions, and if you have any difficulty loading certain things or running something, let's stop and discuss about it. And also with Google Colab, it runs on cloud, and you can ask for GPU support. If you, let me do it again. If you go to runtime and change runtime type, then you can select GPU or TPU, and none, that is CPU. And yeah, you can save your preferences there. All right, so I hope you guys have already this package installed. If you're using other platforms like Spider or something, sometimes it's convenient using Spider. Only thing is that this kind of storytelling won't be there. Like you have text here and then code, and you can read it like a book, which won't be possible in Spider. So, but it's up to you. If you want to use Spider or some other medium to run this, you can actually use that. That case, you just continue copying this code and chunks after chunk and just execute and see the output. Okay, let's begin with the fashion MNest. Okay, here we see two ways to load this fashion MNest data set. First, using Keras, and then using Torch. It's also called Pytorch. And Keras, we will get back to Keras for the next practical. For today, only thing we see is that loading the data set. After that, we continue to use Pytorch for the remaining practical. Okay, and as I'm doing, just go ahead and do with me. First, to run this cell, you just need to hold shift and press enter button. It will run. If you see it is running. Oh, so what we have done is here that Keras package, once you installed, the data sets in that has fashion MNIST. Okay. If you want to load MNIST, then instead of fashion MNIST, you just need to use MNIST, and that will give you MNIST everywhere. Instead of fashion MNIST, you use MNIST.load data. Okay. Or in this cell, what we have seen that train and test data is separated, and in train data, you have input as an X and labels or output as Y. So you can access, once this is executed, you can access the data using these Numpy arrays. Okay. And now to see what is this data, let's plot one image that is first, MNIST has images of digits, and you want to see what is the first digit, then code is something similar. Using matplot library, we can specify what is the figure size, and this line indicates that we are doing it for first image. And in Python, index starts from 0. So this is what, and the data is a grayscale. It has no color component, the digits. So we can very well specify that it's a grayscale what we are looking at, and then output will be gray image. Yeah, let's have a look. And you see that this is the, uh, sorry, we are looking at fashion MNIST, supposed to be the which we look in items in the data set. For MNIST, as images of digits. For fashion MNIST, it's images of the t-shirt, shoes. And as you can see, this first image is a shoe, and it's not very easy to see immediately because the image size is very big. So what we can do is that let's print first 6 images in a small frame, each of them. Then you can make sense of each image. This is the first image and second image, third, and so on. You see that first image is a shoe, and then t-shirt. So, and let's look at the data shape, the size of the data. For that, we can simply use shape command because it's a numpy array. You can use shape, and you see that training set has 60,000 entries. Each one is of image size of 28 times 28. Okay, and then an array of 28 times 28. And Y is a vector. Okay, because it has only 0 to 9. 0 refers to the each item is labeled either 0 to labeled with 0 to 9, because there are 9 classes here, 10 classes here, and labeled from 0 to 9. And that's why Y is a vector. And similarly, test data also a vector, but size of the test data is smaller. We have 10,000 items in test data set. Okay, this is as an easy way to load fashion MNIST from Keras. Uh, can you clarify the input to subplot? This is a question. What exactly you mean by clarify?
I was just wondering
Yeah.
what you put into subplot. So you had 331 plus I. What is that
Yeah.
doing exactly?
Okay. Let me explain this. This actually, if suppose you use 9, okay, what it is specifying is that 3 in the row, okay, 3 in the column. This is a position will be increased by I. So if I use 4 here, it shows that number of columns are 4. You see?
Okay, yeah.
Yeah, that is a number. You can actually give separately that number, but this is a shortcut for
So the
doing that.
first number is number of rows,
Yeah,
and second number is number of columns.
no columns, and this index goes on telling you where to put that image. Because
Okay,
I is 0, first image supposed to be first image, and second image it goes like this. Yeah.
thank you.
Yeah. So yeah, this is clear that this is the data we have. So let's do, how do we do with Pytorch? Okay. There is a question about 1 plus I. Okay. Let's look at adding 1. There is error. You see that the first image is empty. We need to specify where it is. So it essentially says that which image goes where. The this last digit. Okay. Yeah. Thank you. And now, how do we do the same thing in PyTorch? So this code, it selects whether, if you have GPU, it selects GPU, but that's not relevant if you're running on this Google Colab directly, because you can always select GPU. But if you're doing it on your computer and you um, happen to have a GPU in your system, you can certainly use this once you installed PyTorch and Torch Vision. Okay, but for now you can ignore this, and this training set you can get from Torch Vision data sets, fashion amnest. And okay. Somebody asked about, could you share this Python file? As Yoni actually shown, it is available on the course website. All the files are available there. Just access from there, okay? Or the following link can actually lead to the file. And thank you. And so this command essentially tells you, you don't need to go into too many details, but you can play around once you have time, whether you're downloading a train set or if you're downloading test set, you need to make train option being false, and it is true for the training set. Okay. And it transform it to tensor. All we continue to do is in tensor, because that we can actually speed up the process computations on GPU. And so let's run this code. Okay, it has loaded. If you have any doubt, let me know. This next cell I included for the purpose of creating some idea, but it's not really important for us. Sometimes what you want to do is that split the training set into batch sizes and shuffle the data. All these things can be done using data loader, which is available in Torch. Okay, for us, we are not going to use this anymore because we already loaded the set, but you can actually play around with this. Okay, let's anyway run it. And now, as you must have seen that there are tasks in your file. Okay, but no solutions for that task. Let's do the task here, and let's go ahead with printing these images. 6 images, just the way we did earlier. Only thing you need to remember that training set is in tensor form, not in Numpy. But when you're printing, when you're using matplot library, you can't use the tensor directly. So what you need to do is that you need to use Numpy conversion, which can be done as it is implied in a hint. and can convert, and then you print it. So let's just go ahead and create a cell. How do you create? Either you can, once you are here, you can place on code cell. If you want text cell, you can place this, or sometimes you get to see here itself. So just insert code cell and go ahead and write this code, which is same as earlier. Only difference is that you need to add this numpy to the data set. Let's spend a minute on that. And if you have any difficulty, we can discuss. Let's, printing first 6 images. Once you're done, just type done. I will have some understanding that it is happening. Yeah, good. So you can copy the earlier code and just put it there and make little bit changes. Yeah, that's, I think pretty much you guys got it. Okay, then let's like look into this data set. What we have a pointer to it, that is a training set is one pointer, and testing test set is another pointer, and the class label. Okay, let's look into the classes, the labels what we have, and execute this cell. Okay, you see that the classes are, there are 10 classes. First one is a t-shirt, and then is we have trouser, pullovers, dress code, so on until ankle boot. Ankle boot is the last one, and we have seen that first image is in fact probably it's a sneaker. Anyway, let's look into the look at the shape of this data, which we have seen already. Okay, we have a training set 6,000, and each one is uh, an image of size 28 times 28, and the test set is of each image is same size, except that we have only 10,000 samples there. So as I mentioned earlier, we continue to use Pytorch from here, and we use Keras later in the next practical. Now, let's look at the data, like how it is balanced or not. Okay, let's look at how is this data. For zero label is corresponding to t-shirt or top, okay, and 1 is corresponding to trouser, so on like that. 9 is corresponding to ankle boot. So how many are t-shirts or top is 6,000 of them, and so on. It's very well balanced, like each class has 6,000, and so that's why we have 10 classes, so 60,000 in the training set. Okay, and now can you do same thing with the test set? Okay, just you need to modify this code. Just go ahead and do this. Total, there is a question, shouldn't the total train set be 6,000? No, each class has 6,000, so there are 10 classes, so there are 60,000. If you look at the data here, it's a 60,000, not 6,000. this happened to me also earlier, first when I was looking at it. And yeah, that's all right. Uh, and just go ahead and execute this command and see whether it's balanced or not. If it is balanced, just type balance. Otherwise, uh, you can tell what. Good. Yeah, everyone has balance. So let's look at it. So again, it's balance. Okay. Uh, nice. So in test set, we have a equal number of data for each class, and that's a good thing because so we want certain balance in the data to have certain like as Yoni was mentioning, if it is one versus all others, then you have imbalance in the data, but that's not what we are doing here. Okay. Now, this while we looked at fashion MNIST, what happens with MNIST? Can we look into MNIST data and see whether it's balanced or not? Okay, let's again load. Earlier for fashion MNIST, we just used the name train set and test set. To distinguish from that, let's put MNIST in front of it and execute it. Same comments, just execute. And then look at the shape. What you observe that the shape is same, just like fashion MNIST. We have 60,000 images for training and 10,000 images for the testing. And again, each image is of size 21 times 28 times 28. Okay, and let's go ahead and print first 6 images of this MNIST data. Uh, take 1 minute, and when you're done, just say done. So just go to the Fashion MNIST printing cell and copy it, and instead of train set, you just use MNIST in front of it and print it. Just do it. Yeah, you can do it. There is a question. We can transform it. Let's see. Maybe I just did a mistake, and you can very well do it. What I believe that, okay. Yes. What is the type? So easy way to figure out whether given one is what is the type. Let's run. So even if it is, even though it is okay, let's, what we are looking at is data. Say first data element, what is it? It's a tensor already. Even though it's none, it is actually tensor. So you can say like earlier, transform to tensor, or you can put it none. It automatically does tensor, and other options you can explore and just look into check the command. Okay. Do we need to find? Uh, is this a question related to this practical? I think this question has been answered yesterday. We can discuss it once again later. Okay. There is a direct message. I will reply to that later. Anyway, so did you guys run this task 3? Okay, good. Let's have a look at it, how it looks. Yeah, this is how it looks, and how it looks, and seems like a first digit is 5, and then 0, 4, 1, 9, 2, and you can actually print more using just changing. Okay, this, and now what we have done in Fashion MNIST is trying to understand how it is whether it's balanced or not. Okay, just check whether this is balanced or not. Again, we have 10 labels here, 0 to 9, okay? And 0 refers to digit 0. Uh, where are the errors coming up? Could you run this code? You need to change it to data set. You need to look what data set. Did you load MNest train set? Okay. If these comments are same in the cell, after immediately after is this same for MNest. Okay, run this thing and then you need to change this train set to MNest train set. Don't forget to run the code. Okay, every cell you have to run. Just shift enter is running at each cell. Okay. If you want to run all the cells, there is a command run all, but I don't suggest it at here because it's good for practice to go through cell after the cell. Okay. And I'm assuming that it should be solvable, like it should be easy. So if you haven't run, quickly go through the from the top and run the cells quickly. Okay. Hmm. Yeah. Still, is anyone having a problem with running this cell? This one, printing the digits. Okay, good. So it's running for. Okay, cool. So I'm going ahead and let's look at the balance, whether it's balanced or not. Okay. Just the way we have done with the training set for patient data, we need to do it for MNest training set. Okay. And targets is the where the 0 to 9 digits are for each class are there. Just this, this is dot data gives you data and dot targets gives you labels. Okay, you have labels, and in that with how many when you run this, what you get is that how many targets or labels are 0, that is 5923. How many of them are actually labeled as 1, that is 6000. You see that this is not balanced. Okay, for MNest data set it's not balanced, but should be okay. If you look at the number, each number, it's very close to 6000. It's not exactly 6000, but the values are oscillating around just 6000. So sort of not far from 6000. So we should be okay. And what happens with test set? Let's run this command. Again, we in the fashion MNest, we have 1000 exactly for each class. But here again, close to 1000, but not 1000 for each class. Okay. Have a look at it and you see that that either little bit more than 1000 or less than 1000. So for practical reasons, we can actually assume that it's balanced. Okay. Now let's compare training set with the test set. Guys, try to run this each cell, okay, after we moving. So I'm assuming that by the time you reach this cell, a rough comparison, you finish running all the cells before that, okay? Now, let's compute the mean value of the image. Each image has values. Okay, each image is the 28 by 28 image. Okay, and each entry is value takes value between 0 to 255. it's not normalized. We do normalization here, but each array of corresponding image is of size 28 times 28, and each entry is takes value between integer value from 0 to 255. Okay, so we want to create kind of an average of each image and take average of all the images. So we are doing it on MNIST data set. So let's look at MNIST train set, and you access the data, and you collect elements for each k. K is a class, takes 0 to 9. Okay, you take corresponding to first instant, you take corresponding to k is equal to 0. For that is all the images that are labeled as 0. You take that data and compute a mean of it. Okay, and then just to normalize with the maximum value possible, we divide each element by that. And if you look at run this code, you get okay, for each digit, this is the average over all data points available. Okay, corresponding to 0, label 0, and this is the label 1 or class 1. Okay, so on until 10 for 10 labels, and these are the values we get. Let's look at what happens. Uh, it's doubling data is converting to float because all the entries are integer valued, but in Torch, when you're doing tensor operations, it expects a float value. So this is exactly what we are doing. Double is a float value, converts each entry into float, and then you can do the operation. Otherwise, it won't accept the torch main won't operate on that data set if it is integer valued. Okay, I hope that is clear. Now let's do it on test set. Same thing, instead of training we have test set here. Let's run it. Okay, you see that for average value for 0 is this one for training, and for testing this is a value. This very close. If you look at each one, they're very close. How close? Let's have a look. Just plot these values and more clear. Okay, this is how it looks. Okay, for corresponding 0 we have this value, and corresponding to 1 we have this. So they both have a similar uh, values. So in a way, even when you take average, they're well balanced. So that's a good thing. Can we do the same thing for fashion amnest? Okay, let's look at it, and I would suggest you to go through two things we did here. We took a training set from MNIST and test set from MNIST. We ran these two commands, this one and this, and then this plot. So can you do same thing for fashion MNIST? And your code should look like this. I will give you a couple of minutes and just go ahead and execute this. And when you're done, just let me know. Okay. Yeah, the divide is just to have fraction, but it is nothing to do with for this comparison. Okay, you want to have a fraction of okay, let me put it this way. If you're using Julia or something, it generally comes with normalized values, not 0 to 255. Instead, it's a value between 0 and 1. Okay. Uh, if you want to be consistent with that, you divide it. But in if you don't divide, what you get is a value, each entry will be value between 0 and 255. Okay, you can very well plot same way, it doesn't really matter. So you don't need to worry, but in some applications maybe you want to have a normalized one. uh, that, that will be nice, but there is nothing specific. We just want to have a fraction, that's it. I'm waiting for you guys to say done when it is done. And if you have some errors, let us know. Good. So I hope you guys are getting hold of this running codes. That's good. Okay. So we have, let's run the solution. If you must have noticed already that here also we have a very good matching between testing and training. Okay. Yeah. Remember that all these things might not be very useful or something, but it's a good practice. And also like sometimes you want to look into data, if not this data set, something other, and see whether they're balanced or not. These are the small techniques you can actually uh, uh, do to find whether they're balanced or not. Now, let's get into more useful stuff. Let's do classification, binary classification. In class, you must have seen Yoni spoke about classification today, and where what he has explained is that one classes versus all others. Okay, digit one versus non one digit. Okay, instead what we do here that we take 3 as one class. Let's call it as all the images corresponding to digit 3, we put them as a positive class, and all the images corresponding to uh, digit 8, we call them negative class. Okay. uh, there is a question, what are we talking about? Are we referring to this place or what?
Basically anyone. Yeah.
This one.
Yeah. So the number of
So
columns.
yeah, very similar to what we have done here. We are asking like, uh, so the row is the image number, isn't it? So the corresponding target has to be 3. That's what we are saying. Take all the rows or all the images which has label 3.
Okay, and the columns would be?
Columns will be the array corresponding to image 28 by 28. We want all the cells on that.
Yeah.
Okay.
Yeah.
So that's why we put column, all of them. Yeah.
Yeah. So if I had more of them, I just do more columns.
Yeah, right. That's correct.
Yeah. There's a question.
Yeah.
Thank you.
Yeah. Thank you. And so for 8 instead of 3, we have 8. And so we created 2 sets. One is a positive train, and the next one is a negative train. And we also, this is the way you want to see how many images there in positive train. And we can just go ahead and run. Okay. And you see that we are playing with MNIST, so it's not balanced. If it is fashion MNIST, you clearly know that you get 6,000, 6,000, which is not the case in MNIST. So what we get is that more than 6 for positive train and less than 6,000 for negative train. That's all right. They're not too far from each other. And each image is a matrix of size 28, 28. But what we do is that just like in neural networks later, you convert into a vector. Okay, as long as you're consistent with how you're converting, it doesn't really matter which direction you're taking. Either you can actually put all the columns next to each other, one after the other, or rows. But by using this operation, you can convert a matrix to row vector. You can look into why this -1 or something. Okay, but this simply what it does is that it takes the matrix and makes it a vector. And and if you look at the shape of you know that Okay, let's do one thing. Let's insert a code and positive image. And, okay, we have already. First vector is vectorized a row corresponding to vectorized second image, so on. And we do it for all the positive class. You guys can't hear me? Can you hear me now? Yeah, good. I was worried. Okay. So let me repeat what I said. Here we are creating a temporary matrix where each you have a first row which corresponding to a vectorized first image, and second row is vectorized second image, so on. And go ahead, run it. We're running out of time, so let's if you look at the shape, see we have these are the images, number of images, and we have the same number of images, but each one is a rather than 28 by 28. Okay, let's just see how it looks when you use heat map. Okay, this is how it looks. You have these many images. This is each line is an image. Okay, and this is a heat map where when you have a value is 0 to 255. Okay, you can see that brightest spot is where you have a higher value, and darkest spot is where you have a value close to 0. And okay, this is to convert to a vector. Okay, have a look at it. Numpy reshape or Pytorch reshape command. Yes. I will try to post it, but should not be difficult to for you to run this task. But I will put it in the comment section on the last course website. Okay. Yeah. Similarly, can we do it for negatives, temporary negative? We created, and you see that these are the number of images corresponding to digit 8, and each one is vectorized. And then we are doing classification. If you look at classification, there is a beta node. Okay, this linear classification, there is a beta node. So we need to add 1 in the front for the data set. X is the data set, and we need to add 1. That's what we can do by creating a vector with ones, and we were creating linearly. I don't see, no, each image is a vertical line, not a horizontal line. Okay. So each image has a bright spot as well as dark spot, implying that there is some. Okay. Now we are creating a matrix A. In this, if you look at A, should have ones in the first column, and sorry, first column, yes, and the data points after that. The data point should contain both positive and negative. So we are creating a matrix just like that, where A is correspond to X, and then if you look at shape, this is the shape because we are combining both positive images and negative images. Then let's draw the heat map. And this is with all the data points. Okay, this is a whole data set, and then it looks like this. This is up to positive, and this is a negative data set. And okay, then just a little bit data. We need to add labels because first one, all first image up to 6,000 plus or positive, and the other one is negative. That's why we are classifying sensor. And now after that, you know that this classification happens. I hope it's written somewhere. Did I miss something? Where it is written, this operation? Anyway, in supervised learning, you guys must have come across that it's to find the beta in the linear regression. All you need to do is that in this example, all you need to do is that take the pseudo inverse of A and multiply with all the labels, and that's what we do. This is okay. Uh, this is a matrix into multiplied with vector, that is operation torch, and you get beta hat. And if you look at beta hat, okay, this is the size, and that is anticipated because 784 is for the um, image data, and one is for beta naught, which is here, which okay. And once we have this, let's have a look at beta values. These are the beta values. If you normalize the data by 255 everywhere, and you get a different kind of beta values, so no need to worry about it. Now, once we have, how do we classify? As Yoni mentioned in the class, okay, you have X, you have beta. You input X to the beta and get Y, and take the class that maximizes. Okay, that's what we do in the classifier. We define that binary classification. And when you apply on the, for just testing purpose, just apply on the first images in the positive train and negative train. And what you get is that is a, as you expected in positive train, you expect 1, and negative -1, but it might not be true for every image. It first happened to be first for first training element, it is giving you right classification. For the negative set is giving the right classification, but you might actually have a wrong classification. For that, we need to compute accuracy and other things, and true positives, true negatives. And so to do that, let's do so. How many are positive? Okay. This is for testing. Okay, we need to create now for testing. You need to convert into vector just like the training set. That's what we are doing here. Again, just like earlier, we here we created positive train and negative train, and that's what we are doing with the testing also, because then we can apply these values. In testing, you see that there are 1000 for positive and 974 for the negative. Okay, and negative is corresponding to 8, numeric 8, and digit 8, and positive is corresponding to 3. Just earlier. Okay, and now we are classifying each one of them in the test data. Okay, train data we used to find the beta hat, and now we are using that beta. We are classifying all the test images, and once you get some of them are minus and some are positive. Okay, and even though all of them supposed to be positive, we get some negatives. So we need to actually see how many are true positives. You just separate the elements with one. Okay, and you see that they're out of 1010, you get 970 as positives, and so that is a positive number. And similarly, what we can get for negative, and we see that out of 974, 936 are classified correctly for negative. And what is the accuracy and F score? That's what we look at it now. And we just seen how to define accuracy. Accuracy is the true positives, and by, is that correct definition? Yeah, where is accuracy? Accuracy is yeah, the fraction of true right answers by total number of input we gave. So true positive is correct, and true negative is also something correct classification. So we find accuracy to be 96 percentage, and now we can also compute using these true positives and true negative and false positive, false negatives. We can compute precision as well as recall. That's what we do here. And if you look at false positives, we get 38. As you can see, if you just subtract this minus 970, we get this value. And yeah, false negatives are 40. Then you can see that precision is 96.23 percentage. Okay, and recall will be something of the same order. And one last thing is F1 value. Read about these values, and you see that for all these it's reasonably good. Okay, this classifier, linear classifier. It's a homework. Just go ahead and uh, do the same thing when you have a positive being digit 0 and negative being 3. Okay, and then we have C410. We are running slightly. Is this okay if I take another 5 to 10 minutes just to finish this? All right. Then let's look into C410. Yeah, if you have lecture, I will have the record online, so you can access it later. But I'll just quickly finish it in 5-10 minutes. Okay. So just the way we loaded from Torch Vision, the fashion MNest or MNest, we can run them, and we can also get C410. Okay. And these are already downloaded in my system, so I don't need to. But if you're downloading, you get to see the loading going on. And let's have a look at it. What are the classes available in this? There are images of airplane and automobile, bird, cat, deer, and truck, ship, horse. Okay, frog. And let's see the targets, and we get to see the you can access the targets. These are labels of these things, 0 to again 9. 0 correspond to airplane. Okay, if you look at how this data balance, just execute, all are similar. This is a well balanced data set. Okay, each class has 5,000. Okay, and test set also well balanced, so that's nice. And if you look at this shape, for training set, you have 3000, and each one is an image of 32 times 32 times 3. What is 3? So there is a question about clones and detach. Okay. Sometimes what you do, you can directly access targets from here. It gives you warning. So it's better to clone, it says. So you can load it so that you have a different copy rather than this working on the same target set. That's all. And you can very well run without that. And you might see a warning. That's it. And this is the data. Here 3 is corresponding to 3 colors, 3 primary colors. Okay. Yeah, that's exactly correct. And now we can normalize each of them. Again, each color is 0 to 255, but let's look into fraction of these things. And you see that first image actually looks like this, where each one is an array of 3 arrays, and each array is size 32 times 32. Let's not look it that way, but instead let's plot it how it looks. Okay, this is how it looks. How it looks on the first image, and anyone can guess what is it? You can type it there. Seems like you guys can guess easily. I had difficulty when I saw this image first time. Okay, that's correct. You're right. It's frog, and frog is corresponding to label 6, and you see it's a frog. Yeah, right. And this is easy to see when you actually uh, see in a small image, and you see now it looks more like a frog than earlier. Okay, and others are somewhat easier to recognize. And now take out the color components. There are 0 array corresponding to red color, and then you have green colors and blue. Okay, this is the information if you separate them. And what it that it's taking some time. This is an animation of the first 100 images. Okay, and the first 100 images of frog we are separating by putting class, and if you run it, you see that it goes through all the frog images. Okay, you can increase the number and you can slow it down by pressing minus or minus and plus. It will speed up the process. And so the last task is to do it same, but go through all the images and print all, what is in name of that image, the label of that image or target of that image, and image number. Okay, this you can access later, but I would suggest you to just write yourself using the earlier code, modify a little bit and do the same thing. But instead of just frogs, you do it for first 100 images, and the outputs should look similar to this. And let's give a second. Uh, yeah, now it's ready. So what we have here is that this is image number and the name of that image or target of that image. Okay, that's all. And you can slow down this or increase the animation. These are just to play with and learn a little bit. Okay, I hope you guys enjoyed. If you have any question, please feel to ask. This is about today's practical. Okay, any question? thank you, and we'll see you again in the next lecture or during consultancy. Thank you, guys.